All right, so again, given the first question here, what was the water level in the well in 1915? So we should be looking at, oh, excuse me, this table right here, right, this figure. We have water levels, and then we have the dates. So 1915, we have the water level being at the land surface. So straightforward answer right there. What was the water level in the well in 1967? So the same thing. You look at the water level down here in 1967 is pretty much the last recorded stuff, and you match to whatever the Y scale says. Question 16, during what period would the artesian well have been a flowing well? So in order to answer that, you need to know what an artesian well is. So I'll let you answer that on your own based on whatever you read above and what you know from lecture and your book reading. How many highs and lows occur in the water level in any 5-year period? So from this image, you see that, for example, let's take this 5-year period between 1920 and 1925. And we see that there's one high, one low, one high, one low, one high, one low, one high, one low, one high, one low. So there's 5 highs and 5 lows. So in a combination, there are 5 high lows pairings. And if you do the same for any one 5-year period, there's about 5 for each of them. So that would be the question for number 17, fairly straightforward. And what is the cause of these minor fluctuations in the water level in the well? So that I'm going to leave to you, but I want to point out that these highs and lows are spaced out pretty well, meaning the high is pretty much in the middle of 2 lows, or the low is pretty much in the middle of 2 highs for the most part. So that should give you an idea. Okay, now in figure 7 and table 1, the slope of a line joining the subsidence in 1912 and that in 1967 gives the average rate of subsidence for this period. How did the rate of subsidence occurring between 1935 and 1948 differ from the earlier rates? So let's look at those two things, figure 7 and table 1. So figure 7 is right here. So it has a lot of different parts to it. So land surface is this red line that you're seeing. We have depth to water, which is the blue shaded area that you have right here. We have the total groundwater pumpage right here, and you have imported water used for recharge right here. So those are the main 4 lines that you're seeing within the graph, and you have a bunch of supplementary information. So for example, here you have a supplementary information for these periods of time that they're giving you. So now let's go back to what the question is actually asking. So how did the rate of subsidence occurring between 1935 and 1948 differ from the earlier rates? So let's look at the land surface change rather, right? Because that expresses the rate of subsidence. Okay, so land surface seems to be decreasing, and then once you get to about 1938, which is when they're asking us, or 1935, I suppose, in 1948, so about to here, the land surface doesn't decrease very rapidly. So it pretty much, the subsidence itself decreases, or rather, there stops being as much subsidence, okay? And then it asks us in figure 7, explain the cause of this change in the rate of subsidence. Also, I should point out that in here, in the table number 1, you can see that pattern as well, right? You see that in 1935 to 1948, that subsidence rate decreased. The land surface was still lowering, but it was lowering at a much lower rate than it was in other times, okay? All right, and so from the graph right here, you see that this section where the land surface didn't lower as much, it is also characterized by some description down here. So I'll let you read through that. And that's a pretty possible reason of why the land surface subsidence decreased in rate. Okay, so when did subsidence cease according to table 1? So if you go to table 1, where within these years that you're given does the total subsidence just completely stop lowering? So I think you can figure that on your own. And then lastly, we have in 1965, importation of water to the valley began. So you can see that in figure 7. So that would be here, imported water used for recharge. This reduced the need for groundwater withdrawals. In addition, some imported water was used to recharge groundwater through stream channels. This effectively stopped subsidence. Would subsidence resume if imports of water were reduced and pumping of groundwater was increased? So I'll let you figure that on your own based on all that you have done so far, what you have understood from lecture and lab, and what you have seen from all the different graphs within this lab. Alright, you guys, so that is pretty much all we have for lab on subsidence. If you have any questions, please let me know. There's a few references here of what was used, or if you want to go ahead and click on them. Much of this is also the same graphs that you looked at in this document, but feel free to look at them. If you have any questions, as always, let me know. I'm here to help you out. Have a good day.